The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. We're really excited that you can join us today for the session on Building Fortified Homes, Part 2, presented by Fred Malik with IBHS. Thank you for joining our DOE Zero Energy Ready Home Technical Training webinar series. Today's session is one in the continuing series of technical training webinars to support our partners in designing and building DOE Zero Energy Ready Homes. My name is Lindsay Parker. I'm the coordination support for the program, and I'll be covering some general notes on webinar housekeeping. All attendees will be in listen-only mode. However, we invite you to ask questions throughout the session through the questions part of GoToWebinar. We'll be monitoring these throughout the session, and near the end of the webinar, we'll try to cover as many of your questions as possible. Additionally, this session will be recorded and placed on the resources page on the Zero Energy Ready Home website. So as it does take some time for processing these recordings, we appreciate your patience in this effort. But additionally, we will be sending out a PDF of the presentation and webinar after the meeting, as well as some information on upcoming webinars. Now I'm going to hand it over to Joe Nebbia with Newport Partners to talk a little bit about the program and to introduce our presenter.
Hello, thanks Lindsay. Welcome everyone to the DOE Zero Energy Ready Home Program webinar. I'd like to thank everyone for joining us today. I'm excited about our topic. And I'd just like to say a few words about the DOE Zero Energy Ready Home Program and why it's important and why we think there's a connection with what we're going to talk about today in Fortified Home. The DOE Zero Energy Ready program is designed to build houses that are so efficient that a small renewable energy system can offset most or all of the utility costs of the home. In addition to that, it is designed to handle indoor air quality, hot water delivery efficiently. It has renewable ready features, and it has a number of checklists that add a significant amount of quality to the home. And the reason we think this is important in connection with the Fortified program is that if you're going to bother to build a home that performs this well, you want it to last. You're not building a home and putting all the resources into this kind of a home and selling it to a customer who's going to pay the value premium for this kind of a home if the home is not going to last. So while we don't require participation in the Fortified Home Program for certification under the DOE Zero Energy Ready Home Program, we do strongly encourage it, and we think that there's a lot of similarity and overlap in what we're trying to do as far as increasing the performance of homes. So with that, I'd like to go on to introduce our speaker today. This is part 2 in a 2-part series on going green and building a stronger fortified home. Our speaker today is Fred Malik, who's the Director of Fortified Homes Programs at the Insurance Institute for Business and Home Safety. He is responsible for overseeing the day-to-day operations for the Fortified suite of programs which seek to improve property resilience to natural disasters on a local, regional, and national basis. Since taking over the program in 2009, Fred has led Fortified expansion to include new residential and light commercial building standards. Under his leadership, Fortified quickly become the national building standard for resilience. So with that, I'd like to turn it over to Fred. We'll be having questions throughout, and I'd like to encourage you to submit them in writing so that we can answer them as we get them at appropriate points during the presentation. Please don't wait till the end, or the question may not get read. So Fred, take it away.
All right. Well, thank you, Joe, and thank you, Lindsay. We're excited at the Institute about presenting this second part of this two-part series. I'll be starting off our presentation today with a brief, and I mean very brief, review of what we covered in the first session. I do want to encourage you, if you missed that, it should be up on the DOE website and available for viewing there. We covered some pretty important information there about the value proposition, the business case, and a couple of the technical aspects of building design that drive the Fortified program. Just a little bit more about myself today. I'm a builder by trade. I built, I was a residential and commercial builder developer for a little over 15 years before taking over the program here at IBHS, and so I feel that I bring a pretty practical, pragmatic viewpoint to what we're trying to accomplish so that we have a chance of making it affordable and doable. So hopefully you'll find that influence in what we talk about today. We do want to start off with a couple of poll questions just so I can get a feel for the audience. So Lindsay's going to fire off a couple of poll questions. They're just going to help me understand the size of the participants that we've got viewing our webinar today, the types of projects you work on, and a little bit about who's in the audience. So Lindsay, why don't you go ahead and do that?
Sure thing, Fred. I'm going to be launching the first poll, which is how many projects do you work on in a given year? Is it 1 to 50, 51 to 100, up to 250? And I'll give the audience a little bit of time to respond before closing the poll. All right, thank you everyone. I'm closing the poll now. I'll share it with all of you. It looks like 73% of the people in attendance have worked on 1 to 50 projects in a given year. The lowest being 6%, doing between 1 and 100 to 250. And Fred, you want to leave another poll?
Sure. Let's go ahead and find out who's in the audience out there.
Sure. The next question is, please identify the types of projects you work on most frequently. Either new homes, or you're remodeling existing homes, both or neither. All right, thank you. I'm closing the poll now. I'll share you the results. It looks like 52% are working on both new or existing homes, new and existing homes.
Okay.
And one more. We have, please state your affiliation. Are you a builder, a remodeler, or a developer, a lender or realtor, a rater or inspector, or do you work with utilities or manufacturers? All right, thank you for voting. I'm closing the poll. Looks like we have a pretty wide range audience out there with 45% of you are builders, 31% are work with vendors or manufacturers or utilities. All right, thank you.
All right, well, thanks very much. That's very helpful, and it'll help me hopefully present this material in a way that's meaningful to the bulk of the audience that's out there. So let's go ahead and get started. As Joe and Lindsay have talked about, DOE, through support of their Zero Energy Ready Home program, has asked us to participate in this webinar series to provide some technical knowledge about disaster resilience, and that really falls into the lasts better kind of category and value proposition that that DOE's programs seek to bring to the market. So that's what we'll be focusing on today is quality of construction, durability, disaster resistance, and lower cost of ownership. In our first portion of this series, we talked about who IBHS is. We talked about some important definitions relative to the building code and fortified home. We talked about a fair amount about why fortified. We made a business case and presented the value proposition so that builders and others could inform their consumers, their customers, their buyers about fortified home and what makes it important. And then we dove into some of the science behind fortified, and in particular we talked about how buildings are designed and how they interact with the wind in particular. We do offer guidance on other hazards, but there is no section of the country that is not affected by high wind, whether you're in a coastal community or an inland community. So again, if you missed that presentation, please go look at the archive version on the website. So today we're going to be talking about the technical requirements for fortified home. How do you do it? If you're a builder, you're a remodeler, or even if you're a homeowner and you're interested in upgrading the resilience of your home, how would you go about doing that? So we're going to talk about what the most vulnerable systems are today. We're going to talk about a couple of the dominant hazards that we deal with in the form of hurricane and high wind and hail. So we cover both the coastal communities and inland communities. And then we'll get into the nitty-gritty details about the different upgrades that are necessary to the systems that are vulnerable to high winds in a new home or an existing home. And we'll talk about some of the keys to success, the things that are important, like documenting what you've done so that when an evaluator, a fortified evaluator, comes out to do an evaluation of a home, all of the things that are now concealed by finished materials can be adequately verified. And lastly, we'll conclude with some examples of recognition and a little bit more information on how you might be able to get involved and get started building fortified homes. So just as a brief review, Fortified Home is a hazard-specific program that is divided into 3 levels: bronze, silver, and gold. And each level, we're increasing the resilience of the home, and we are addressing specific systems in a definite priority. For example, we know that the roof system is the most vulnerable system in the house to high winds and other hazards. So we start there, and then we move up to openings, and then finally to the structural, the load path, which as we add those different levels of resilience, the home gets stronger and stronger and can resist higher and higher winds. Just a couple of other review points here. Fortified home does require independent verification. That's done by certified fortified evaluators who are essentially chosen from groups of 3 folks: licensed design professionals, licensed contractors, and licensed or registered home inspectors. They come to there's a preliminary training that they do online, and then there's an in-person class that they attend and an exam that they have to pass, and then there's some continuing education. Certification lasts for 3 years. Details about that training are on our website at disastersafety.org. The designations are valid for 5 years, and I did get a question after the last webinar about why, if we make these changes and the changes are essentially permanent, why do we have to go back out and look at a house every 5 years? And the simple answer to that question is it's because of the way the roof cover in particular weathers. If you use shingles, then shingles can weather rapidly despite what their warranty may say, and other roofing materials for that matter can weather differently in different environments. There's also a need to follow up when after 5 years, a home may have experienced some severe weather event, or there may be additions to the house. So that's why there's a 5-year interval. The recertification process is not nearly as intense as the initial certification process, but there is a redesignation that's needed every 5 years. Automatic reminders are sent to registered owners prior to the expiration of the designation so that they have plenty of warning that they need to have a redesignation performed. And then, as I mentioned, the redesignation focuses on the roof and then any additions or repairs that may have been made in the intervening 5 years. So briefly, why fortified? Well, we covered this last time, but it's the little things that matter. It's the old adage that a house or a chain is only as strong as its weakest link really applies to a home as well. And so little things like how the nails or fasteners that are used to secure the roof deck, whether the roof deck is sealed, how the roof is tied down to the rest of the house, types of openings or fixtures in openings, and whether or not they're protected. All of those things add up to resilience. And just as a refresher, this is a video from our test laboratory. If you'll recall, IBHS is a nonprofit. We're 100% funded by property insurance and reinsurance companies, and we conduct building science. And then based on the outcome of those experiments and our research done in the field, both pre and post disaster, that's what makes up my program. That's what goes into Fortified. So this is a house. On the left side of this house is the duplex is actually built exactly the same, except for on the left side of the house, the roof deck is sealed with a tape that we identify in our standard, and you'll see just how that one minor improvement can dramatically impact how a house can weather a severe thunderstorm or tropical storm. Whoops. So you'll notice that the roof cover begins to peel off. The wind speeds are far below what the product is rated for. We didn't even get above 70 miles an hour before the roof cover started to fail. You saw the tape there on the roof covers up the designed gaps in the roof decking. And if you don't have that protection, the water can just pour into the home, and even after the event is over, you have the residual effects of saturated drywall, saturated insulation, the damage to the personal property on the inside of the home. And that's really what Fortified is about. It's about protecting the property and its contents. What you're seeing now is the side with the sealed deck, a little bit of insulation on the floor when we dropped the attic access panel, but the damage was limited to the exterior, which is really significant because it means that the cost to repair is manageable, and the property owner can reoccupy the house right away. They can stay there while the house is being repaired. On the right side, you'll see that just that one improvement reduced the damage by up to 300%, and that $17,000 in damage on the right-hand side doesn't include displacement or disruption, which would actually have happened here because the water inundated the property and it could not be habitable for some time. So it's the little things that matter, and the science behind these things is important. I also had a question last time because we focus a lot, we show a lot of wood construction in our demonstrations, our experiments. We talk a lot about wood construction and also shingles because those are the dominant construction techniques that are used in the United States. This, however, is a demonstration of block construction. And simply changing the material, if it's not done correctly and it's not verified, doesn't necessarily mean that you'll end up with a more resistant building. So this is an example of a structure, two structures built out of block, one built stronger, one built typically, and you'll see that as the roof starts to fail, it causes problems for the rest of the structure. Now, this building actually that's going to fail here actually performed fairly well until the front window was broken. And once that window broke, the building was not designed to keep resisting the pressures on both sides of the wall, interior and exterior. It lifted up the roof, broke the bond beam. There wasn't adequate reinforcement, And believe it or not, those winds of just 100 miles an hour were able to force the block to expand and fail. You'll notice that on the roof covering was flapping long before that, so this structure would have been inundated with water long before the structural failure happened. But on the right-hand side, you'll notice the window is broken as well, but there's no movement. The roof covering is intact because it's installed properly and it's designed adequately. So just because you're using something like block or concrete doesn't necessarily mean that you're going to outperform wood frame if your block or concrete is not installed and designed correctly. So just a couple of reminders about the benefits to builders and why builders should pay attention to Fortified and consider building their homes fortified. This is an opportunity to build trust with your customers, to be the expert. Building to code means nothing to consumers. They all assume that everybody builds to code and it's all the same everywhere. And we know that that's not the case. So building trust is important, and third-party verification that comes with participating in Fortified helps to do that. You're offering protection of what's priceless to your property owners or to your consumers. There's differentiation opportunities and recognition, particularly important these days when you're competing not only against other new homes and other resales that are at market prices, but also when you're competing against lower price alternatives like foreclosures or short sales. This is an opportunity to show value and hopefully overcome some of those pricing disparities. Using the Fortified Home mark, we have collateral materials, we have logos that you can use. You also have the opportunity to control the process, especially on new homes. You can partner with a Fortified evaluator, and you can be interacting with that evaluator to do quality control of your product as it's being built, so you can be in control of that process as opposed to having a homeowner come to you after they've closed and seek to have you make some adjustments that could have been more cost effectively made if they were identified early in the process. And then there's growing demand. We've got thousands of requests for evaluations. We're spreading from the Gulf Coast up through the Mid-Atlantic, and now we're starting to get interest inland as well, as we hear frequently about these severe tornadoes and thunderstorm events that are out in the Midwest. As far as affordability goes, I don't have affordability here because it's not consistent across every market, but I just got an email this morning from a consumer in Alabama where there are Fortified incentives, and that customer who is living in a lower price point home has reduced their hurricane, the cost of their hurricane insurance by over $3,000 in the last 2 years, and it's now become an affordable component of home ownership as opposed to something that was a potential barrier for them to be able to stay in their home. So their payback period on their investment to upgrade that existing home to Fortified Silver is just under 5 years. All right, so as we talked about last time, design wind speed determines what program you should participate in, whether it's Fortified Home Hurricane or Fortified Home High Wind and Hail. This is a wind speed map that's in a reference called ASCE, which is American Society of Civil Engineers, 705. There's an updated version called 710. But you'll notice the contours that are along the right side, particularly around from Texas up to the coast, and you'll see numbers associated with that. And numbers go anywhere from 90 up to 150. They're even higher in ASCE 710. They go up into the 180s. And then you'll see as you move inland, the last prominent contour is the 90-mile-an-hour contour, and that applies to the bulk of the rest of the United States. Unfortunately, wind design and construction requirements in the building code have not kept pace inland the way they have on the coast, and so that's why we still end up with prescriptive roof attachment requirements, for example, that lead to frequent roof failures and significant damage during straight line wind events like thunderstorms or more aggressive wind events like tornadoes. In addition to wind contours, we also have guidance that identifies where you need to be paying attention to hail. Hail is a huge source of insured losses every year. Billions of dollars are spent every year by insurance companies replacing roof covering as a result of hail. So we have a hail map, and if you fall in one of these blue counties, you have hail risk. And if you're away from the coast, you're required to upgrade a home to comply with the high wind standard as well as the hail standard, which brings in some impact resistance requirements. And this is just a very short video that explains our hail research. We're the only research facility in the world that can do hail research the way you're going to see now. Standard testing is a single ball, either steel or solid ice ball, that is shot against roof covering. We are able to create thousands of hailstones and deliver them on a subject. So take a watch and a listen here.
At IBHS, we're always trying to come up with safer, stronger buildings and ways to make the existing buildings safer and stronger. So we test commercial and residential full-scale structures against a variety of natural hazards: wind, wildfire, water, and now hail. So we get the hazard, the phenomenon correct, and then see what happens to a structure. We've been working on this project for about 2 years. The hailstones that we make in the laboratory are spherical. We have 3 different sizes. We have a 1 inch in diameter, 1.5 inch, and a 2 inch diameter. We use an 80% seltzer water plus 20% regular tap water, and we inject it into the molds to make our ices so that they match well with the densities that we see of natural hailstones. We did hundreds of experiments using thousands and thousands of stones to come up with the recipe that we're using for our demonstration. You never have a storm that has all hailstones exactly the same size. So we're trying to give a distribution, and we have more of the smaller stones and less of the larger stones to match up what you would see happening in the real world. The demonstration is designed to basically allow us to showcase the devices that we've developed, show that we can create a full-scale hailstorm, and look at the relative differences in performances of the materials on the building, as well as some things that you would commonly have outside your house. We're always looking for ways to improve the performance, see how building materials compare to each other, and what ways we can make the building stronger and safer.
So needless to say, it's a fun place to come to work every day when we get to go to the lab and do that kind of stuff. Frequently, a good analogy to use when you're trying to explain who we are to somebody who's never heard of IBHS, IIHS crash tests cars, and we crash test houses. So that's a good way of referring to who we are and what we do, explaining what we do. So what that means is there are different standards that are appropriate depending on where you are in the country, but wherever you are encountering those hazards, you should be building the same way. We shouldn't have big variabilities from coastal communities in Texas to coastal communities in North Carolina. The hurricane peril is consistent fairly so across that geography. And same goes with inland risk for high wind and hail. So we have the hazards separated so that they're appropriate and affordable depending on where you live. So here's a breakdown of the systems that are focused on in the 2 hazards. Hurricane, in the bronze level, we focus on the roof and the attic. In silver, we focus on the openings, and in gold, we fortify the structure. We make sure there's a continuous load path. On the high wind and hail side, we fortify the roof first. Then we pay attention to other structures like gables, porches, carports, and chimneys, which are very vulnerable to failure during high wind, and when they fail, they tend to compromise the primary structure. And then finally, we focus on fortifying garage doors and the continuous load path in gold for high wind and hail. So I'm going to get into the actual technical details of each level depending on the hazard, and that's where we're going to spend the balance of our time together. But before I do, I want to just stop and ask Joe if there's any questions that I need to take right now.
Yeah, Fred, we've got actually a number of questions. If you'd like, I can go through them, and you can say whether you'll cover it more later or not, but I think there are a number of good ones, so I think I'll just list a few here.
Go ahead.
So first, we had one participant ask if you could talk a little bit about the difference between sealed roof deck and a sealed attic, and whether there's any interaction between a sealed roof deck and any sort of roof ventilation system.
Okay, so a sealed roof deck actually refers to the gaps in the roof decking material. We look at attic ventilation systems separately, but at the same time as we consider the rest of the roof system. And a sealed attic would really address the attic ventilation system vulnerabilities, particularly at the soffit and then through any off-ridge or ridge venting. So hopefully that explains the difference. There will be some more clarity around that issue when we get into the explanation of how you affect these different upgrades as we go on. But that's the difference. Sealing the roof deck has to do with keeping water out that would potentially infiltrate the property if the roof covering was lost. Sealing or addressing the risk of the attic ventilation system, one of the techniques to do that is to seal off the attic.
Okay, the next question is related to fire protection. Does Fortified deal with fire protection at all?
Well, the Institute has guidance for fire resistance, wildfire resistance, as well as internal fire losses. We have not released a designation standard under the Fortified Home Program yet that deals with either one of those fire losses, but those are coming in the future. We do have good guidance on disastersafety.org relative to wildfire, and we are now beginning to incorporate the internal fire requirements that are found in the latest editions of the building code, residential building codes.
Okay, and then I'll ask one more, and I think maybe save a few more for later. What sort of guidance does Fortify offer or requirements do you have in place that are linked to ensuring the homes also meet all applicable codes and safety standards?
So we're not replacing, that's a great question by the way, we're not replacing the standard inspection process that deals with building code requirements. What we're doing is we're taking a very focused look at key vulnerable systems, and where those systems require upgrading, we ensure that our standard is never below the current building code, and in some cases, or in many cases, exceeds the building code. So our inspection process is not designed to replace the standard inspection process that the local building authority has in place. We just focus on the resilience components as they relate to the Fortified Home Program.
Okay, thanks, Fred. We do have a few more, but I think they can wait until after you go through the rest of your presentation.
Okay, all right, well, we'll stop again once we start getting through the levels. Okay, so Fortified Bronze. Remember from our brief overview, Fortified Bronze, we're dealing with the roof. The roof system also includes attic ventilation systems, and if a home has a gable roof shape, we'll deal with some elements of the gable in bronze. So our first requirement, and this is, you'll get the feel for us focusing on the roof as an entire system. The first requirement is we look at the roof decking. If you're retrofitting a house, the house has to have at least a 7/16 inch thick roof deck. We know that the code allows something less than that in some places, but we require 7/16 inch or greater. If you're building a new home, we recommend strongly that you go to 5/8 or 19/32. It just gives you more meat to tie into, to attach to with the fasteners that secure the roof deck and the other material that gets applied to the roof deck. This is requirement is consistent across both hazards. In terms of attaching that roof decking material, if you're installing a new roof on a new home, the standardized prescriptive method for doing that in complying with Fortified is nailing off the roof with 8D ring shank nails at 6 inches on center over the entire roof. There may be, depending on where you are, your wind speed and your exposure category, a need to increase that spacing at the corners. And we talked about this last time, that where the wind moves around the building and at corners is where the highest pressures are generated. So you may end up going to a 4-inch on center spacing at the corners, but generally speaking, over the bulk of the roof, 6 inches on center, edges and field will get you where you need to be. If you're retrofitting an existing roof, and this is for the hurricane peril, by the way, if you're retrofitting an existing roof, when you're recovering it, for example, if the roof has staples or 6D nails, the roof has to be re-nailed. There's no supplemental attachment that can make those fasteners adequate. You have to re-nail the deck. So you just nail it off at 6 inches on center with 8D ring shank nails. If you have 6 inches on center on the edges and 12 inches in the field, then simply adding an additional ring shank fastener in between the existing fasteners in the field will get you where you need to be for the roof deck attachment under the hurricane standard. On high wind and hail, and you should notice, if I didn't point it out, but you should notice that at the bottom of these slides there's little badges or logos that represent the different hazards, and as we move along you'll see that change as the component or the system that we're talking about relates to the different hazards. So that'll be how you can keep track of this, especially if you're looking at this presentation again later. For high wind and hail, if you're installing a new deck, then again 8D ring shank nails is the preferable spacing and fastener type. If you're retrofitting an existing deck, you have a little bit more flexibility here. 8D common nails at 6 inches on center across the deck can be adequate. They don't have to be ring shank nails, although we do recommend them. But when you start to get spacing that is greater than 6 inches on the edges or 12 inches in the field, you need to supplement that attachment by adding ring shank nails at the interval in between the existing fasteners. The next step in fortifying the roof system is sealing the deck, which we had the question on earlier. If you are sealing the deck, if you're building or retrofitting in in a hurricane-prone area, sealing the roof deck is mandatory for all roofs, even if you're not replacing the roof covering. That can be accomplished if you are replacing the roof covering or you're installing new roof covering. You can seal the deck from the top side. That's going to be your most affordable option. You have 3 options, and we're going to cover those here in just a bit. The most affordable option is applying the tape that you see in the picture. It's a 6-inch wide modified bitumen tape or an acrylic tape like is used with the zip system. That will be fine. If you are in a high wind and hail area, if you're building new, you need to seal the deck. If you're replacing the roof cover, you need to seal the deck. But if you have a roof cover that is in good condition and does not need to be replaced at the time of the evaluation, then it's not mandatory for you to seal the deck, but that will be looked at again in 5 years when the designation is being reevaluated. So here's some techniques to seal the deck. The tape, as you can see, is one way. Another way, an acceptable way, is to install a fully adhered membrane. Now in some locations this is a good option. Some of you may be familiar with this as being used at the eaves in the valleys for ice damming. In warmer climates, you can get away with sealing the deck with a fully adhered membrane, the entire deck. In your northern climates, where you do have some propensity for severe winter weather, you want to look at one of the other systems, preferably. Otherwise, you have to do a little bit more planning in design because you can trap moisture on the wrong side of the deck in those colder climates. And there's no evidence that is a problem, but we just want to make sure that people are aware that there is a potential consequence there, and there are other methods that would be better suited for northern climates, like the tape, or using a synthetic underlayment. Now, the key about synthetic underlayments, they're great. They have good tear resistance, but if you want to use it as a sealed roof deck system, then there are some very specific installation requirements that have to be followed. The material must be lapped greater than a typical installation. You need to install it using button cap nails. You can't just staple it down. Most manufacturers that produce this type of material have something they call the high wind and prolonged exposure installation requirements. Now, I can tell you from experience that almost nobody looks at those requirements when they use this product, but it's there. And we tend to default to those installation requirements, but we do have prescriptive guidance about the overlaps and the size and location of the button cap nails that are to be used. But the important thing is if you use this product, you want to install it per the high wind and prolonged exposure requirements, because the intent here is to have this material keep the water out in the event that the primary roof covering is lost. And finally, there's one other method of sealing the deck. This is going to be more appropriate for retrofitting an existing home where the roof covering is in good shape. You can seal the deck from the underside using a qualified two-part spray-applied polyurethane foam adhesive. That's a lot of words, but it's a pretty simple product. It's a closed cell foam, and the requirement only requires you to apply the product to the horizontal and vertical seams of the roof deck. Now, this is one place where if you are sealing the attic off and you're applying an insulation product to the underside of the deck, you can use a closed cell foam insulation and effectively seal the deck. But using the foam adhesive, and that's why that's in yellow, gives you an added benefit of securing the deck or adding supplemental deck attachments. So, for example, if you are sealing the deck using this method with a closed cell foam adhesive, you do not need to re-nail the deck if that also proves to be necessary. You can simply use this foam to double or even triple the strength of that attachment. Okay, and so now we're getting to the roof coverings. In the last session we did get some questions about why did you talk all about shingles, how about metal, how about something else. Well, we'll talk about those things now. Fortified Home does not show preference to one material or another. We're material agnostic. There are right ways and wrong ways to install any of these types of materials or select the appropriate materials, and that's what we're going to spend a little bit of time talking about now. For shingles, most important thing is to pick a properly rated shingle for the wind speed that's supposed that is prevalent at this building site. As I mentioned, there's two references referred to in the code, ASC 705, which is probably the most common at this point, but the transition to ASC 710 is coming with the 2012 and later IRC. And you can see here we provide tables that tell you what the wind speed is and what the classification of the rating of the shingle product is required to be. Now, most of these products as well, when you get into the Class H's that are rated under ASTM D7158, do have installation requirements as well, 6 fasteners instead of 4, for example, in high wind installations. Now, if you are in a high wind or high wind and hail location, there is an impact rated requirement, rating requirement that is applicable under Fortified Home. The wind speed is calibrated to 110, which, if you'll recall, is 20 miles greater than the standard wind speed of 90 miles an hour that's referred to on the wind speed maps. So that dictates either Class F, Class G, or Class H shingle. and the shingle must also have a Class 4 impact rating. One of the ways you can find out what the wind speed is of your project, or what the design wind speed should be for your project, is to go to this free resource by the Applied Technology Council, the ATC. They have a wind speed by location tool. You can put in the address or the Latin lawn if you know it. You hit the button there on the lower right hand side of the screen that says get wind speed, and you'll get back some results here. Places a pin on a map so you can make sure that it got you in the general location. And under ASC 710, most residential construction falls into risk category 2. I tell you that the design wind speed is 140 miles an hour. And if you're using ASC 705, the wind speed is 113. Now I will tell you that despite the big differences in the values there, 113 to 140, the way the pressures are calculated under using those two tools, you end up in roughly the same spot. So despite the higher number of 140 under ASC 710, the pressure that's generated by those wind speeds is roughly equivalent to the pressures generated under the old methodology that would say the design wind speed is 113. And that's for our office in Tampa, by the way. So when you're looking at this material on shingles, the wrappers is where the material is identified to meet these standards. So it's critically important that if you're building product or you're installing product on a retrofit house, you keep some of the wrappers so that we know what was installed there. You'll notice here under this red circle, you've got in accordance with ASTM 3161 Class F. There's also a Class H rating for this product as well. Here's another label from another shingle that tells you the wind rating of the shingle. And this one actually also is an impact rated shingle. So here you can see that it says also classified as to impact resistance. This is the type of documentation that's going to be needed to verify that a house is in compliance. Another thing that we pay attention to on the roof system is the drip edge. I realize this is a little out of order because we were just talking about the roof covering, but the drip edge is a requirement. You have to have it. There are different nailing requirements depending on which hazard you're retrofitting. I won't get into those specifics, but it's essentially the difference between 4 inches and 6 inches, and we stagger the nails in the hurricane to keep that leading edge protected. For metal roofs, metal can perform very well in high wind conditions, provided that you select the appropriate metal. So the thickness is dictated by the substrate that it will be applied to and the wind speed and exposure category. So what we look for as far as the metal roof goes is this type of engineering. Now this is generally available from the manufacturer. However, we've found in places like North Carolina where metal roofs are very popular, local distributors of metal roofing products may not provide this engineering unless it's requested. I don't understand that. I don't know how you're expected to install their product appropriately if they don't provide this to you, but that's a fact. It happens. But this is the type of information that you would want to have if you're a builder specifying metal roofs. You want to know what the gauge of the metal is, and then what the attachment requirements are, what size fastener, over what type of deck, and at what spacing for the given wind speed. We'll also be looking for this type of information about this roof, and this is again for the hurricane hazard. For high wind and hail, metal roofing also has to have an impact rating. The tests vary, so we accept different tests for this product. Either FM 4473, Class 4, or Class 3. People don't know to look for it, but essentially what it is it's relates to this little lip that's on the leading edge of that product, which keeps the wind that's being driven up the plane of the roof from being blown inside through the hole that it covers. So TAS 100A is what we look for in the hurricane standard. There is no requirement on ridge venting in high wind and hail. The other element of the attic ventilation system that we pay attention to is the soffits. This is particularly important if you use vinyl or aluminum soffits, and those soffits are greater than 12 inches wide. I know that it's a very common design element now in terms of energy efficiency to have wider soffits to provide more shade and therefore reduce the air conditioning requirements in the building. But as you extend those soffits, you need to properly brace the material. Again, this is something that has been prescribed by the manufacturers of these products for years. I built a lot of houses with vinyl soffits, never knew that if they were over 12 inches they had to be braced in the center. Well, now I do, and now you do. So if you are building any soffit that is greater than 12 inches and covering it with vinyl or aluminum, you need to add this brace in the center. Here's a picture of some folks installing it on a Habitat house, but that's what it looks like. It's a nailer mid-span between the fascia and the wall. Now, we talked a little bit about gables. If you have a gable that has an overhang and the overhang is constructed using outlooker framing or framing that is cantilevered over the exterior wall, it's important that those overhangs be attached to the structure with metal connectors. If you don't do that, and these overhangs in particular get greater than 12 inches, they become very susceptible to high winds, and we see this all the time in post-event where gable end overhangs are peeled back because the outlookers were not adequately attached to the structure. Finally, we're talking about one last component of the attic ventilation system, and that is if your gables are vented as part of your ventilation strategy, you need to provide some sort of protection for those vents in the hurricane areas only that keeps water out. We've done a fair amount of testing that wind-driven rain just pours into houses through these vents, and it's important to protect those things. It can either be done with a shutter on the outside that is temporary and can be installed whenever a storm is threatening, or on the inside. And then last thing about gables that we pay attention to in the fortified bronze for hurricane and fortified silver for high wind is sheathing on the gable end wall. Now this sheathing right here does not qualify. It's not a structural sheathing. This one happens to be sheetrock, but it does not have the structural strength that it needs to have. Even if the product says it does, we've done the calculations and we've seen it not work. So we like to see a structural sheathing like wood, plywood, or OSB here. There's an example of a conventionally framed gable that has structural sheathing. Now, many times when we get to a house to do an evaluation, these materials, these kinds of things are concealed. We have something called the roofing compliance form, which can be completed by a roofer or general contractor that can attest to what was installed, and then they sign it and affix their license number to it, so that, you know, that if they're less than honest, we have a way of taking some action. But we do use roofing compliance forms in cases where our evaluator cannot see what it was installed. We don't use the compliance form by itself. There has to be other documentation provided, like the wrappers from the shingles, for example, and other things. But compliance forms can be used to help build that documentation file up. One other thing that you may be asking yourself is, well, how do I get my hands on this documentation if we threw it away? Well, there is a site out there called approvalzoom.com that has built a search engine that searches product approval websites in Florida at the ICC and Texas, the TDI. and will pull back testing standards and reports for products. And they have built a FORTIFIED filter into their search engine, which can be a very effective tool for helping to locate documentation and verification materials for the products that you use. All right, I'm going to move on to silver. I know that I've got to pick up the pace a little bit here, but Joe, are there any questions I need to hit right now, or can I keep on going?
I think just two hopefully quick ones. The first is, can you talk about the adhesive you mentioned on the underside of the roof? Is that any spray foam, polyurethane spray foam insulation, or is it a specific adhesive that's required?
So there are two types of closed cell foam that you can find. One is an insulation product only, and the other is a two-part closed cell foam adhesive. If you need the additional attachment strength, the adhesive is the only product that will work. And if there's not just one, there's many. Many of the folks that manufacture open cell and closed cell foam have a closed cell foam adhesive. So there's not just one product out there. But if you need the supplemental deck attachment, then the adhesive is the only product that will work. If you are only seeking to seal the deck is attached properly, closed cell foam insulation can be used. We have specifics about the makeups of those materials in the standard themselves, so you can provide those to your supplier and they can tell you which of their products meet those requirements.
Okay, thanks, Fred. And the other one that we have is a question on your comments on structural sheathing. We had a question on whether CIS panels, structurally insulated sheathing panels, qualify for your requirements regarding to structural sheathing.
So we have a number of fortified homes that have been designated that are SIPs homes. There are other challenges that come along with SIPs, but in terms of meeting the structural sheathing requirement, that we haven't seen any challenges as far as that goes. The other issues come into how the wall panels are connected to one another and how the roof is connected to the wall panel, but in terms of structural sheathing, SIPs panels really don't present any kind of unique challenge.
And Fred, just to clarify, that was CIS, S-I-S, not SIPs.
Oh, okay.
Any difference?
There can be. So if we're talking about structural insulated foam, then yes, we've noticed that there are some challenges there. That doesn't mean that it won't work. It just means that there's a significant amount of documentation that has to be supplied and engineering that has to be undertaken to ensure that the product meets our requirements. But the foam insulation, or I'm sorry, the structural insulated foam panels, we have not seen many that were successful. As a matter of fact, I can't think of one that was successful.
Okay, thanks.
Okay, so going on with silver now, we're going to get into protecting openings and attached structures. Opening protection in coastal areas is pretty standard. If you're from those areas, this isn't news to you. Opening protection can come in a variety of shapes, sizes, and materials. You can have metal panels, fabric panels, roll down, what we call passive systems, where the homeowner doesn't have to really do anything. That would be impact-rated windows and doors, or some other kind of automated system that stays in place all the time. An active system is a system where a homeowner has to actually install it when a storm is coming. Those are examples of what you see now. The important thing is the openings have to be protected with a tested and approved system. We list a number of different testing standards that we accept, but the products have to be tested in accordance with those standards. They have to meet those standards, and they have to be for large missile impact. And that's in the hurricane areas. Opening protection is not a requirement in high wind and hail areas. Similarly, garage doors need to be both pressure rated, and if they have glazing, they have to be impact rated, or the entire opening has to be protected in the hurricane hazard. So let me be very clear about that. This door that you see in this picture has no glazing. It is required to be properly pressure rated for the site, the design wind speed and exposure category, under the silver designation standard for hurricane. This same door would be required for the gold under the high wind and hail. If this door had glazing, it had glass in any part of this door, for the hurricane standard, this door would have to be either impact rated as well, or this entire opening, this 16-foot wide opening, would have to be protected with a shutter system of some type. And here's an example of that. Getting back to gables, we do look at gables again in silver under both the high wind and hail and the hurricane standard, and we're looking for the gables to be braced. We provide in our standard a prescriptive method for doing that works. It's a very conservative method, and it's pretty expensive and labor intensive to do, but the end result we know is adequate. There are other prescriptive methods. For example, this one that I show here in the inset, the drawing, which is from the wood frame construction manual, where when a gable is originally being constructed, if it's going to be platform framed, you can run some sleepers here and then a strap down before you apply your sheathing. Other alternatives can be engineered specifically for your project by your design engineer, and we'll accept those provided that they look at or they address the appropriate concerns. But bottom line is gables have to be braced. That's for platform framed gables. A gable that is balloon framed, in other words where you have a continuous framing member from the floor all the way up past the ceiling line and up to the top of the gable in one continuous stud, that's called balloon framing. Balloon framing is inherently braced because there's no mid-span connection point like this at the bottom chord here where you've got a hinge point that's vulnerable to high wind. For attached structures like porches and carports, a load path is critically important to keep those secondary elements from compromising the primary structure. So we're looking for connections at the roof framing member to the beam or column, from the beam to the column, and then from the column to the slab. And that would be the silver requirement in both hurricane and high wind and hail. So that's silver in a nutshell, and here's gold. Gold is primarily focusing on a continuous load path. We do also focus on design pressure ratings of windows and exterior doors in gold. Now, just to avoid confusion, design pressure is an element we pay attention to for the garage door in silver because it's such a large opening in the house. But recognizing that working in particular on an existing home, you may not know what the design pressure is of a particular window or door. It is not necessary to verify that design pressure until you get to gold if you're building to resist hurricanes. Chimneys need to be addressed in gold for hurricane and in silver for high wind and hail. Chimneys have evolved a lot over the last few years, that most of them are framed now, and they're just simply covering a metal flue from a prefab fireplace. And we know that these wood boxes that are surrounding that metal flue are generally loosely attached to the roof deck. They rarely get adequately tied back into the roof structure. So we do require that chimney be tied into the roof structure, and that's to avoid something like this. So the bottom picture shows a hole where the chimney used to be, and this is a house 2 doors away where that chimney now resides, on the back deck of the neighbor's house. Obviously, from a structural perspective, this isn't too terrible to repair, but just think of the volume of water that could be dumped in here. And notice this roof cover performed great. This one did not so great. this roof cover is keeping the water out until the chimney gets compromised, and now we've got just a giant hole allowing water to pour in. Again, focus on systems, focus on things that need to be addressed appropriately. And finally, we want to make sure that the entire house has a load path. We're looking for a roof-to-wall connection, a wall-to-floor connection, a wall-to-foundation connection, and these connections need to be lined up, hence the word continuous. If they are offset by even a few inches, more than say 3.5 inches, the continuous load path is broken and these parts start to act independently of one another. So that's the 3 levels of designation. I'm going to keep pushing through and cover the rest of the stuff, and we'll take final questions at the end. Some important information for verifying compliance. Since this is an inspection-based program, we do require an on-site visit from an evaluator. The evaluator provides us with copious amounts of pictures and other types of documentation so we can verify what's done. This is an example of a pretty good picture. It shows us one elevation of the house, and we can see that the roof deck is being sealed, actually using a couple of different methods. And on this particular house, they went so far as to seal the deck from the inside as well. So this is a pretty extreme example, but pictures are great. They show us what's going on. It puts the person doing the analysis in the position of the evaluator, so we know what's happening on site. You'll see that those are 3 pictures of the same house during the different phases of construction. But once you get to this point, it's really hard to tell that this house is fortified and this one's not. So we need to get this record so that we know how the house was built before it got concealed. To create a documentation file, if you're a builder, you can work with your evaluator to accumulate this documentation and hand them a documentation file that can be transmitted to us via email or through our online evaluation system. Pictures, invoices, bills of lading, that type of thing are all potential sources for documentation. This is an exceptional example of a picture. It's labeled really well. It shows all the different elements of the load path. We understand clearly what's supposed to be, or what's trying to be communicated. This is another good one where it's showing us the location of the roof fasteners. We can see the shiners. We know what the spacing is. We know which house it applies to. So this is a good picture. It's in focus. It's well lit. In contrast, this is a fairly poor picture. It's out of focus. It's dimly lit. I can't read it. We can't accept this as documentation of anything. So that's in a nutshell. What we're asking for is good quality pictures, and where pictures can't tell the entire story. For example, if I'm looking at a picture of a shingle installed, I don't know what the wind rating is of that shingle. I need something else to tell me what that shingle is. Where pictures cannot tell the story, we need other documentation to verify what's there. So how do insurers and other stakeholders, how do they know that a house has been built fortified? Well, there's really only one way, and that's we issue certificates. IBHS issues the certificates of compliance, and the certificates that we issue, silver and gold, and they have the property, the date of designation. There's a unique identifying number called the Fortified ID number down here, and then an expiration date so that it's clear to whomever is looking at the certificate when the designation will expire. Commonly get asked, well, how can we get involved? I'm sold. I want to do this. I'm excited about it. You can get involved by helping to bring clarity to the resilience movement when you're out talking to your consumers or other stakeholders, talking about the things that you've learned here today and the things that you can learn on our website. You can make a commitment to being a fortified builder or remodeler or being a stakeholder in your community that is going to promote resilience so that your community has a better chance of weathering these disasters. You can also attend training. We have the evaluator training I mentioned. It's a certification training to become an evaluator. You cannot evaluate your own work, similar to what's happening, on the ResNet side. in support of Energy Star and Zero Energy Ready Home program, but you can be certified to inspect other people's work. And we are going to be releasing later this year a Fortified Wise Contractor designation, which anybody can attend and get basic information about the program, like we've talked about in these two seminars, and earn a credential and the right to use the logo as a Fortified Wise Contractor. And that's really the last bit of information I have. I'll leave these links up on the website, or I'm sorry, on the screen, so you can see them. If you can't write them down right now, just go to disastersafety.org/fortified, and you'll find all this information on our website. And Joe, with that, I'll go ahead and open it up for questions. And we did have a couple of poll questions we wanted to run here at the end.
Sure. Well, while we're getting the polls ready, I'll throw a couple questions at you. The first is that we had a request for you to show the first picture of exceptional documentation you had on your slide. I don't know if you're able to scroll back to that.
Okay, there you go.
All right, so we can just leave that up maybe while we talk about the next question. We got this one kind of early on, but I thought it was general, so we'll wait till the end. Has there been any study on the incremental cost of either a package or individual items that you're recommending, and is that available to people who want to look at it?
So we have done some analysis of the costs for some of these things. The most common retrofits that we see that are needed. We have a piece that we're finishing development on now that is available upon request that kind of outlines some of these things. I will tell you that generally speaking, if you live in a place that is has a building code that is close to what the International Residential Code is and is well enforced, you'll probably see a 0 to 3% increase in cost, depending on what your building style is and what you may have to do differently, and particularly if you do opening protection or not. And this is in coastal areas. The non-coastal areas, it's again probably 0 to 2% if you're in an area where the code is relatively recent and it's well enforced. If you are starting in a place where you're not building adequately to the most recent codes, or the codes aren't relatively well enforced, then you're likely to see the increase in cost going all the way to gold to be somewhere around 5%. Those are some good benchmarks, but we see many places where the cost differential is negligible, and we're talking about maybe a few $100s and in some cases $0.
Okay, thanks, Fred. The next question, I think you may have dealt with this at the end of your slides, but where should people go if they want to just look at sort of a summary of your requirements?
So we have something called the Technical Requirement Summaries, and they are on disastersafety.org/fortified, and you'll see a menu of the different I'm going to try to show that to you now. The different collateral materials we have fact sheets, summaries and guides and standards. If you go to summaries, guides, and standards, there's what we call the technical requirement summaries here. These are 2 to 4 pages long, and they cover everything I just talked about, but in a very brief and specific, concise manner.
Okay, thanks, Fred. We did get somewhat of a specific question here at the end, asking you to talk about the use of plywood as a connection from a double top plate to the stud. If that's too specific, let us know, but if you feel like you can answer that, go ahead.
Well, I can tell you that can be an effective technique. You have to lap the areas of the wall properly. There has to be enough of an overlap, and the fasteners and fastener spacing that are used to transfer the loads to the plywood need to be adequately designed. So that can be an effective technique. We've seen it done a lot. One of the things I would say is that it's important for a structural engineer to provide the builder with appropriate guidance on using that particular technique. And one of the other things I wanted to point out in this particular example that you see here on the screen, you'll notice that all of the connectors and connections are on the same side of the wall. You know, I see all the time, and I used to actually build this way, where those connections, particularly at the top, are on the inside of the wall because they're easier to get on. But actually, the appropriate way to execute a load path using these types of connectors is to put all the connections on the outside. So, Joe, I kind of covered two things there. The simple answer to your specific question is yes, plywood or OSB can be used as an effective connection in the load path, the creation of a load path, provided that it's lapping an appropriate distance and the fasteners are at appropriate schedule.
Okay, thanks, Fred. Another question we got was regarding attaching solar panels to the roof. And do you have any guidance in your documents or on your website about that interaction and wind resistance or whatever other considerations need to be taken into account?
Sure. Photovoltaics are a relatively new system for us to be looking at. We are looking at that now. We've got a series of experiments that will be happening later this year in our large format test facility where we can generate more specific science and guidance along those lines. So that will be coming. That's a good reason to keep checking disastersafety.org. Many of the manufacturers who have photovoltaic systems have looked at it from a high wind perspective, and it's a lot like some of the other systems that we talked about today. If you know what you're looking for, and now that you've been educated, you know how to identify that you need to look for the specific installations for high wind. Many of the photovoltaic suppliers or manufacturers have engineering guidance for high wind installations, and we generally have not seen any issues with that. What we see are issues when people don't follow that guidance and simply install it in a kind of a more standard application. But we will have coming in the near future more specific and targeted guidance with regard to photovoltaics, both on residential and commercial properties.
Okay, thanks, Fred. Another kind of specific question we had was regarding magnesium oxide sheathing and whether there had been any specific testing done with relation to that product, or whether there was any guidance related to that product or class of products.
Simple answer there is no. We have not looked at that specific class of products.
Okay. And the final question that we have here today was more of a general one. It's where the presentation can be found after this webinar. And the DOE Zero Energy Ready Home Program posts all of its webinars on our website, which can be easily reached by Googling DOE Zero Energy Ready Home or by typing www.buildings.energy.gov/0. And we will be posting both the slides and the recording. It may take a few days to get up there. So if we have no further questions, I think we'll launch into the poll questions. Thanks again, Fred, for all of your help today. And everyone, if you could participate in these last few polls before we wrap up, that would be great.
Here's we have two more poll questions to ask. The first is, what do you see as the biggest challenge in deciding to build or retrofit a fortified home? From what you've learned from the webinar today, is it difficulty showing the value to homeowners or demonstrating the value to my company or industry? Is it maybe the cost? or lack of consumer awareness of the program, or potentially none, and you're ready to start building one today. I'll wait a few more seconds for more people to put in their vote. Okay, great. Thank you. I'm closing the poll now. I'll show you the results. Looks about 56% of the people who voted say that there's lack of consumer awareness in the program. The next poll we have is, what would you identify as the most compelling reason to build or retrofit a fortified home? Is it that it provides information about the properties I'm selling or insuring? Provides additional value for my customers? Does it provide a way for my company to build trust with buyers? Maybe it offers a way to differentiate my company in the market, or having an independent third party verify work and materials. All right, go ahead and close the poll. Thank you for all who participated. It looks like 66% of you said that the most compelling reason to build a fortified home is that it provides additional value for my customers. Otherwise, it offers a way to differentiate my company in the market.
Well, that's great. I think in our last webinar we did, the response that finished first was differentiation. So I'm glad that people have seen value. I also wanted to just mention that on our website we have a videos tab at disastersafety.org, and if you are planning on engaging stakeholders or consumers in conversations about Fortified, those videos are there for you to use, the ones where the home is destroyed by the wind, the water intrusion, the block failures, wildfire demonstrations are all up there. So please feel free to take a look at those and consider using those in your conversations with folks that you deal with.
Well, thank you again, Fred, for spending some time with us, and thank you to all of our participants today. We know your time is valuable, and we're happy to have you here. If you're interested in the DOE Zero Energy Ready Home Program and would like to learn more, again, our website is www.buildings.energy.gov/zero. You can find information about other trainings and webinars or events. You can find out what builders are participating and where they are in the country. You can look at our program requirements, and you can access the webinar recordings. I'd also like to encourage everyone to take a look at what's really a great new resource that the Department of Energy has developed called the Building America Solution Center, which has just a wealth of knowledge from decades of research into building science, and can be a great way to dig in at many different levels, understanding high-performance building. So with that, I'd like to wish you all a good day, and we look forward to hearing from you soon.